Hello everyone and welcome to distance time graphs. Here we're going to look at what distance time graphs are and what we can calculate from them. So let me show you basically what a distance time graph is. If we imagine we've got some object, maybe a little car, and what we're going to do is we're going to use a graph to describe how the car is moving. So what could happen is the car will start moving from a fixed position over to somewhere else. When the car is stationary, the graph will be flat. So what's happened so far is the car has moved a distance away from where it started to somewhere else over, in this case, 5 seconds. It's moved 5 meters. For 4 seconds, between 5 seconds and 9 seconds, the car was stationary. So what this graph is doing is it's describing how the car has moved. Now the car now is going to turn around for 3 seconds and move back to nearly where it started from. It's still 1 meter away from its original position, but what basically happens is if the graph turns around and starts coming back downwards, then the car turns around and moves back to where it started, or moves towards where it started. If it were to move right down to the bottom, then that would be exactly where it started from. So this is what a distance time graph is. It calculates how far a object, a person, a cyclist, a runner, a dog, a car, a train has travelled over a certain period of time. And in this case, it's travelled 5 meters in 5 seconds, or 1 meter every second. And going backwards, it's travelled 4 meters in 3 seconds. So we can do some calculations of speed and how fast this car has travelled. We can see that it's travelled faster in the second section than the first section because the graph is steeper in the second section. It's travelled more distance over a shorter period of time as a ratio. Now what I refer to as the ratio there is the gradient of the graph. The gradient of the graph, remember, is difference in y divided by difference in x. We've seen that earlier in the course. We generally write it with these little symbols here. So if you were to write it fully, you'd write difference in y divided by difference in x, but mathematicians, being lazy as we are, we like to use symbols to represent words. So we're using difference in y divided by difference in x as our gradient calculation. I'll show you how to do that in a second. What this leads to, though, is a calculation where speed is calculated by doing the distance travelled divided by the time that it took to travel that distance in. And if you were to do an average speed, that would be the total distance travelled divided by the total time it took to travel that distance. So what we're going to do now is we're going to do part 1, which is a calculation of the speed in the 3 different sections of this diagram here. In section A, we'll calculate the gradient. So section A will be difference in y divided by difference in x to calculate the speed. And when we calculate the speed, effectively we're doing a calculation of distance divided by time. So, how far did we travel in section A? We travelled from 8 meters away to 3 meters away. Effectively, we've moved 5 meters closer to where we wanted to measure our distance from. And how long did it take us to do that? It took us 3 seconds to do that, so 5 divided by 3. 5 divided by 3 is about 1.67 meters per second. So that's the answer to part A. In section A, those first 3 seconds, we travelled about 1.67 meters per second. In section B, the graph is flat. This is section B along here. The graph is flat here. We didn't move an inch, we didn't move any meters at all in those 3 seconds. So here the speed is equal to 0. In this case here we were stationary during those 3 seconds. And for section C, this is section C here, this is going to be again a distance divided by time calculation. And let's use the graph to measure our distance travelled. We've moved from 3 meters down here in this first part of the line up to 10 meters. So that would be using a rise of 7. And from this starting point here, we started at 6 seconds up to 12 seconds. So that will be a run of 6 seconds. So 7 divided by 6 is about 1.17 meters per second. And there we are, those are the 3 answers to these questions here. And what we're going to do now is we're going to look at how we would calculate the average speed for the whole journey. Well, if we remember, the average speed is equal to the total distance divided by the total time. So let's now go ahead and work out that average speed. So the average speed is total distance, average speed is the total distance we've travelled. Now we've travelled from 8 down to 3, and then from 3 up to 10, so that's gone from 5 meters and then an extra 7 meters, divided by the total distance, the total time that we took, which was 12 seconds. The total 12 there, so that's 12 divided by 12, so the average speed for this journey was 1 meter every second. So we do include the time that we are stationary for when we calculate an average speed. Okay, your turn to have a go at this one now. Pause the video and give this question a go. Okay, so calculate the speed in the 3 different sections. We've got part A, part B and part C. In part A, the graph was stationary, so no meters per second there, stationary, 0 meters per second. In part B, we need to look at our distance travelled. The total distance we've travelled is from 1 meter away to 8 meters away, so that would be 7. Divide that by how long it took us to travel those 7 meters from 1 to 8. That was from time 4 to time 7, so that would be 3 seconds it took us to do that travelling in. 3 seconds along, 7 meters up, so 7 divided by 3. 7 divided by 3 is 2.3 recurring, so we'll write 2.33 meters per second. And in section C, we've gone from 8 meters away to 10 meters away, so that's travelled 2 meters over that time. And how long did it take us to do that? It took us from 7 seconds to 12 seconds, so that's 5. So it's 5 on the time there, distance divided by time, so that would be 0.4 meters per second. So effectively that's travelling 40 centimeters every second for 5 seconds. And another question for you to have a go at now, which is calculate the average speed for the whole journey. Pause the video and give this one a go. Okay, so average speed is calculated by total distance divided by total time. So the total distance travelled here would be from 1 meter away to 10 meters away, so that's going to be 9 meters travelled. Divided by how long that took us to do that, so that would be from 0 seconds to 12 seconds, so 9 divided by 12, that's 3/4, or 0.75 meters per second. So there we are, it was total distance divided by total time. It took us 9 meters, so it took us 12 seconds to travel 9 meters, so 75 centimeters every second. Alright then, this is a question for you to have a go at now, and in this question you're going to practice drawing your distance time graphs. We've got some information down the side here and a little question for you to have a go at afterwards, so pause the video and give this question a go. Okay, so start at 0 kilometers, hopefully you've drawn out the graph for this one, and travel at 20 kilometers per hour, so that's the units on the axes here, kilometers and hours on the time and distance axis, for 2 hours. Okay, so 20 kilometers per hour for 2 hours. So in the first hour, I'm traveling 20 kilometers, and in the second hour, I'm also traveling 20 kilometers. So there we are, we've done step 1. Rest for 1 hour. So I'll now rest for 1 hour, that's a horizontal straight line. And then travel towards the start, going at 30 kilometers in 3 hours. So different language here. This is travel 20 kilometers per hour for 2 hours, whereas this is travel towards the start, going 30 kilometers in 3 hours. So I've got to travel 30 kilometers back in 3 hours. So that will intersect back at 6:10. Or after 3 hours, it will be travelling back by 30 kilometers. Now when you've drawn these, hopefully you've used a ruler. I can't on my tablet here, as I'm doing as best as I can. And the final part is, for the last part of the journey, what is the speed? So we've done these types of calculations. This will be distance divided by time. So the distance travelled here would be going backwards by 30 meters, and that would be happening over 3 hours. And 30 divided by 3 is 10. Now we need to make sure we've got the units correct here. That would be 10 kilometers per hour. So that would be the final answer in this question. So hopefully you've got the graph and you've got the answer to the little question. We've got a couple more coming up of these, so have a go at this next one here. Draw yourself out a fresh pair of axes and then have a go at this question here. Pause the video and give this one a go. Okay, so in this question we need to start 50 kilometers from home and travel 30 kilometers towards home at 15 kilometers per hour. Well, if we're going at 15 kilometers per hour and we've got to travel 30 kilometers, that's going to take us 2 hours to travel those 30 kilometers in. So 2 hours, and we want to travel 30 kilometers. That will be going from here to here. Then we rest for 3 hours, 1, 2, 3 hours rest, and then go 20 kilometers towards home in 1 hour. Now this is distance from home, so we've got to come back down 20 kilometers in 1 hour. So this is the graph for question 4. And in this case, it finds for the last part of the journey, what is the speed? So that's going to be distance divided by time. The distance travelled here was 20 kilometers per hour, and that was just for 1 hour. So that's just going to be 20 divided by 1, which is 20 kilometers per hour. So there we are, that's the shape of the graph, and this is the question answer to the last part. 2 more of these to have a go at then. Have a go at this one now. Pause the video and give this one a go. Make sure you're drawing out a fresh graph for me. Okay, so in this question we've got to start 10 kilometers away from home. So 10 kilometers away from home. Travel 40 kilometers per hour away from home for 1 hour. So that's going to be for 1 hour, 40 kilometers. That's quite a steep graph to this point up here. Rest for 1 hour. So resting now for 1 hour. And then travel 20 kilometers towards home in the next 4 hours. So that's going to be 20 kilometers back, that's 30 over 4 hours. So this will be at this point over here. So straight line connecting those 2 points from there to there. So that's the answer for question 5, but let's have a go at the last part. For the last part of the journey, what is the speed? Well, in this case here, we've travelled 20 kilometers over 4 hours. So if you've travelled 20 kilometers over 4 hours, that's going to be 5 kilometers each hour. So 5 kilometers per hour, we've done the division of 20 divided by 4. Let's move on to the final one of this little section here. Pause the video and give this question a go. Okay, so in this question we've got to start 30 kilometers from home, and then we've got to travel 10 kilometers per hour towards home for 3 hours. So that would be 1, 2, 3. So each hour we've travelled 10 kilometers back towards home. Then we've got a rest for 1 hour, so that would be resting for 1 hour, and then travel 50 kilometers away from home in 2 hours. So 20 kilometers in, 50 kilometers in 2 hours. So that would be up to this point here, connecting that point to that point there. Good. So that's the graph for this final question here. And for the last part of the journey, what is the speed? Well, we've travelled here 50 kilometers in 2 hours. So that's 50 divided by 2, which is 25 kilometers per hour. Okay, let's move on to the next question then. And what I want you to do is take this question here and tell me what the story of this graph is. Include the speeds in your story and maybe make it a bit inventive as well. Pause the video and give this question a go. Okay, so what we could do then is Timmy is cycling to the sweet store. Timmy is cycling to the sweet store, and his starting cycling speed was 100 meters in 50 seconds. So 100 divided by 50 is 2 meters per second. So in the first section here, Timmy has travelled 2 meters per second. But Timmy then forgets that he was meant to call in on Johnny before he gets to the sweet store. So he has to go backwards to go and get Johnny. And in that time, he's travelled from 100 metres away from home to 40 metres away from home. So that's a distance change of 60 divided by 20 seconds. So that's going to be 3 metres per second. So that's faster than the initial speed there. And then Timmy and Johnny then cycled to the sweet store from 40 metres to 160 metres. So that's 120 metres they both have to cycle over a time of 10, 20, 30 over 30 seconds. So that's going to be 4 metres per second. So it's slowly getting quicker. And you can tell they're getting quicker because the gradient of the graph is getting steeper. Then they're flat at that section there, which means they've arrived at the sweet store and they've started to pick their sweets. So this is travelling at 2 meters per second here, then 3 meters per second going backwards towards home, and then it's 4 meters per second going away from home towards the sweet store. Okay, we're going to have a go at one more question before we move on to the worksheet. I'll give you a chance to have a go at this question before I show you how to do the answers. But what I'd like you to focus on in this question is that we're going to be converting from minutes into hours. So when you answer the first question, what I'd like you to do is answer it in terms of kilometers per hour. So think about what 30 minutes is in terms of hours, and then do your calculation in terms of hours. Okay, so pause the video and give this question a go. Okay, so in the first part here, we're working out the speed that Sean travels at in the first half an hour. So Sean has travelled from 0 up to 20, so that's going to be a difference here of 20 divided by 30 minutes. Now we don't divide by 30 here. If we want a speed in terms of kilometers per hour, we divide by half an hour, or in other words 0.5. So what we've done there is we've converted 30 minutes into 0.5 hours. We've had to do a conversion there from minutes to hours. How many minutes, how many decimal hours is in 30 minutes? And that's 0.5 hours. So 20 divided by 0.5 is 40. So the answer to the first part is 40 kilometers per hour. We've had to do a conversion from minutes into hours. Part B is how long did Sean rest for? Well, that's in between 30 to 45 minutes. So we can write 15 minutes here. You don't have to write 0.25 hours. And Sean travels back home at a speed of 60 kilometers per hour. Complete the graph and calculate the time she will be back home. Well, let's just do some converting here. If we've got 60 kilometers equals 1 hour, that's the current speed she's going at. 60 kilometers is 1 hour, and she's only got 20 kilometers to home, 20 kilometers, then she's only going to need 1/3 of an hour. Now, how long is 1/3 of an hour? Well, there are 60 minutes in an hour. 1/3 of 60 is 20 minutes. So Sean's only going to need 20 minutes to get back home. So currently she's at 45, so I need her to go up to 65, and that's when she'll be back home, in 20 minutes time. So I'll continue the graph by going in a straight line from where she was to where she needs to be in 20 minutes. So I've done a little conversion there. 60 kilometers is 1 hour, so therefore 20 kilometers is only needed to be travelled in for a third of an hour at 60 kilometers per hour. Okay, so there's the answer to that question 8 there. So what I'd like you to do now is come out of the video, click on the link in the description of the video, and that will take you to the worksheet. I've got 5 questions for you to have a go at. Either you can print the questions off and then have a go at them on the worksheet. Either you can grab your maths book and have a go in your maths book, or you can just do question after question, one at a time on another piece of paper and just tick yourself off as you go along. So you can either do all of them in one go, or you can just do question by question. So let's have a go at the first one then. Pause the video and give this one a go. Okay, so in the first part we need to calculate the speed from 9:05 to 9:35. So that's this first blue line from here to here. Reading the graph, this will be a distance of 7 kilometers, and it's traveled in 30 minutes, or in other words, half an hour. So the calculation here is going to be distance divided by time. It's not divided by 30, even though that's 30 minutes, yes. It's going to be 0.5, because it's 0.5 hours. And that's going to give us 14 kilometers per hour. Calculate the speed from 9:45 till 10:05. Okay, so 9:45 till 10:05. That's 20 minutes. So that's going to be 1/3 of an hour. So 20 minutes. Needed a quick conversion into hours. That's 1/3 of an hour. So now I'm going to do, it's still from 7 down to 0, so it's going to be 7 divided by 1/3. And if you don't know, if you do 7 divided by 1/3, that's the same as doing 7 times 3. So that's going to be 21 kilometers per hour. And part C is, what was the average speed for the whole journey? Well, going right back to the start of the video, if you want to work out average speed, you need to do total distance divided by total time. Total distance divided by total time. The total distance travelled here was 7 going out and 7 coming back. So 14 kilometres in total. And how long did it take? It went from 9:05 to 10:05, so that's 1 hour. So that's 14 kilometres per hour was the average speed of whatever thing was travelling here. So we do include this time period here that we were stationary for, that 15-minute period there, so 10-minute period there, we do include that. So 14 kilometers per hour, that's the answer to question 1. Let's now move on to question 2. If you haven't done it, pause the video and make sure you have a go at it. Okay, so part A, how far did Emily travel in total? Well, she travelled 12 kilometres out and 12 kilometres back again, so in total 24 kilometres. Calculate the speed as Emily travels away from home. Well, she travels 12 kilometres in 60 minutes, so that's 1 hour. 1 hour, so that's going to be 12 kilometres per hour. And calculate the speed as Emily travels towards her home. Well, that's going from 12 to 0, so that's 12 again. But this is only over 40 minutes, from 80 to 120. Now, 40 minutes needs a quick conversion. 40 minutes is 2/3 of an hour. So we're going to be doing here 12 divided by 2/3. And what you might want to do first is do 2 divided by 3 equals, and then that's the value of 2/3, and it should give you 0.6 recurring. And then you can do 12 divided by answer button, and that will give you 18. So the answer here is 18 kilometers per hour. So these are the 3 answers for question 2. If you've got those right, let's move on to question 3 now. Pause the video and give this one a go. Okay, so how long did it take Joe to travel away from home? So it took him, reading the graph here, took him 45 minutes to travel away from home. 45 minutes. Part B is what speed did he travel at during the first stage of his journey? Well, first of all, 45 needs a conversion into hours. That's going to be 3/4 of an hour. And next, he travels 40 kilometers in that time. So it's going to be 40 divided by 3/4. So let's grab the calculator. We could do it in brackets as well. 40 divided by, in brackets, 3 divided by 4, close brackets, 160 divided by 3, or 53.3 kilometers per hour. So 53.3 kilometers per hour, but he only did that for 45 minutes, so he then travelled 40 kilometers. And how long was Joe stationary for? Well, that's from 2:45 till 2:30, so 3:30, that would be another 45 minutes. Moving on to the next part of question 3, what speed is his travel on his return? Well, he travelled back by 40 kilometers, and that only happened over half an hour. So 40 divided by 0.5 hours, that will give you 80 kilometers per hour. And part E is what was Joe's average speed for the whole journey? Well, Joe has travelled 80 kilometers in his journey overall, and it's taken him from 2 o'clock till 4 o'clock, so that's 2 hours. So that's going to be 40 kilometers per hour on average for the whole journey, including the time that he was resting for. Okay, let's move on to question 4 then. Pause the video and give this question a go. Okay, so how far was Sean from her home at 9:30? Let's read the graph, go down to 9:30 and up to, that's 10 kilometers away from her home. What was her speed from 9:40 till 10 o'clock? So 9:40 was this point here, and 10 o'clock was this point here. Well, during this time, she's travelled 10 to 20, so that's 10 kilometers, divided by, and that's going to be 20 minutes from 9:40 till 10 o'clock. So 20 minutes. 20 minutes needs a little conversion. 20 minutes will be 1/3 of an hour. So 10 divided by 1/3, and 10 divided by 1/3 is 30. 30 kilometers per hour. And moving on to part C, what's our average speed from 9 o'clock till 10 o'clock? Well, from 9 o'clock it was at 0, 10 o'clock she was at 20, so that total distance there was 20 divided by the time it took her. That was from 1 hour, from 9 till 10, so it would be 20 kilometers per hour. And moving on to the last part of question 4, what was her speed from 10:30 to 11:20? So that was from this part here to this part down here. That's 11:20. So that's from 10:30 till 11:20. That's 50 minutes. And 50 minutes needs a conversion. That's going to be 5/6 of an hour. Because if you take an hour, 60 minutes, divide it by 6, you've got 10 minutes, times it up by 5, you've got 50 minutes, so 5/6 of an hour. And during that time, they've travelled 20 kilometres from 20 back home, so that's going to be 20 divided by 5/6. And let's do it on the calculator, 20 divided by, and then in brackets, 5 divided by 6, 24 kilometres per hour. And part E, what was Sean's average speed for the whole journey? Well, she's travelled 40 kilometres in the whole journey, and it's taken her from 9 o'clock till 11:20. That's 2 hours 20 minutes. So it's going to be 2 1/3, because you've got 2 hours and then the 20 minutes is 1/3 of an hour. So 2 third, if you do on your calculator 2 plus 1 divided by 3, then that will give you 7 divided by 3. 7 thirds, so 40 divided by 2 and a third. You can do that on your calculator. 40 divided by answer, in my case, is going to be 17.1. 17.1 kilometers per hour on average, including the time she was resting for. And moving on to the final question then, question 5. Pause the video and give this question a go. Okay, question 5. What was the initial speed of Aaron's journey? Well, he started at 1:30 and finished at 2:30, so that's an hour. And then it's going to be a total travel of 10. So that's going to be 10 divided by 1. That's nice and easy. That's 10 kilometers per hour. For how long was Aaron stationary in total? Well, he had a bit here and a bit up here, and each box is representing 15 minutes. So that's half an hour here, an hour here, so that's 1.5 hours. 1 hour, 30 minutes. And moving on to part C now. What was Aaron's speed as he returned home? Well, as he returned home, he travelled from 18 kilometres away to 0 kilometres away. And at this time here, that was perfectly at 5 o'clock. So that's taken him 2 hours to do that. 18 divided by 2, that's 9 kilometres per hour. And what was Aaron's average speed for just the parts of the journey he was moving for? Right, okay, so we have to now exclude this part here and exclude this part here. So the total time, let's work that out, that would be 1 hour from here to here. Plus we've got from 3 o'clock till 4 o'clock, that's another 1 hour. Plus then 2 hours coming back, so in total Aaron was moving for 4 hours. And how far has Aaron travelled in this time? Well, he's travelled 18 kilometres away from home, then 18 kilometres back home, so that would be 36 kilometres travelled over 4 hours that he was actually moving for, so that would be 9 kilometres per hour. So there we are, that's the answer to that question, and that is the lesson complete on distance time graphs. Keep an eye out for the velocity time graphs video, and thanks very much for watching.